Problem 10. KM and LN are diameters. Now you can see this circle actually is kind of ellipsy. It's not a very good circle, but we can still work with it. So they say that this is a diameter and that's a diameter. Find the indicated measures. Well, if this is a diameter, that means this whole thing is a straight line. And if I were to add up the angles, including OL, then I would get 180 degrees. That's also true for the arcs. The arcs at the angles start at the center of the circle are equal to the angles. So the question is, what is this arc OL? Well, all three of these arcs have to add up to half of the circle. So I can say 105, why OF, plus 35, right? Not a very good 5 there, my pen's running out, plus this mystery one, I'll just go ahead and call it X, all right? Has to equal to 180. I'm going to get markers so you can see this. My pen's dying out. Equals 180. All right? So I add these two up. 105 plus 35 is 140. Plus X equals 180. So I get, subtract 140 from both sides. I get X equals 40 degrees. So this is 40 degrees, both for the angle in here and the arc. So I'm put 40 degrees right there. They ask for angle OPM. Well, I'm going to basically, I can look at my vertical angle here. That's 105 because two vertical angles are congruent. And they want to know OPM, which starts here, goes to here. So it'll be 40 plus 105, or 145. Angle NOL, so they want to, our arc NOL is all of this added together. Well, that actually cuts these, that's half of the circle, it's a semicircle, so that actually is just 180 degrees. I don't have to do any addition there. Arc ONM. So they want to find arc ONM. Well, if this is 145, let's see. I know that this angle right here is congruent to these two. 35 plus 40 is 75. So that's actually 75 degrees. So if I get my calculator, just to make sure, I could have also added all four of these and subtracted from 360. So we've got 105 plus 35 plus 40 plus 105 plus 75, enter, 360. So that's right. So ONM would just be 105 plus the 35, ONM plus the 75. So when I add those up together, 105 plus 35 plus 75, I get 215. Angle NPM, we've already figured out, is 75. And angle OMK, so that's almost the whole thing. That will just be 360 degrees minus this angle. 360 minus 35, which would be 325 degrees. Now on to problem 11. Find the arc of DF. So I'm trying to find this arc right here, the measure of arc DF. Since these are congruent chords, then the arcs that they intercept are congruent. I can just write 130 degrees and I'm done. That's it. Find MJ, the arc length of JML. JML. Well, congruent here, right? These are right angles. So these are actually also going to be congruent arcs here. So I just add the 250s and I get 100. Find X. Well, on this next problem, I know that if I divide this arc by 2, I get X. So X equals 80 over 2, which is 40. On to problem 14. I'm trying to find the X. So X is this angle. Now, because this is 90 degrees right here, that automatically tells me that this chord here cuts a semicircle, which even though it doesn't look like it, that means it's a diameter. And since they're congruent chords, the angles that are inscribed are congruent. So I can just say that x is 90 degrees. I'm going to have you skip this one.